Okay, we have here another integral on the board. This one is from the MIT Integration Bee 2012, problem 21. We have the integral of 2dx over cosine x minus sine x all squared. Okay, when I started working on this, I was really looking for a creative way and was playing around with it, and for some reason I just really wasn't coming up with the creative solution. So I kind of just did the boring thing and multiplied out the denominator, and let's just see how that goes. So if we square this, we're going to end up with cosine squared x plus sine squared x. And when we do the middle terms, we're going to end up with sine x. I don't know why I boxed myself in that way. So we multiply out the middle terms, we ended up with minus 2 sine x cos x. We have the nice identity that sine squared x plus cosine squared x equals 1, so I can rewrite that way. And for 2 sine x, I just noticed this is actually the same thing as sine of 2x. So what I'm going to do is just go ahead and rewrite that in this form. So we'll end up with just 1 minus sine of 2x. And then from here, I'd kind of like to have something in the numerator to do a u substitution, but we've got nothing right now. So what I'm going to do is multiply this by the conjugate. In the numerator and denominator, multiply by 1 plus sine of 2x. And then when we multiply that through, what's going to happen is we're going to have in the denominator we'll have 1 minus sine squared 2x. And then we're going to have here just 1 plus sine of 2x dx. Then here what I'm going to do is we're going to use the identity for 1 minus sine squared and write this as cosine squared of 2x. And then what I can do, because we're adding in the numerator, I can actually split this into two integrals, dividing the cosine squared in. For the first integral, we're going to have 1 over cosine squared 2x. That's the same thing as secant squared 2x. Then for our second integral, let's see, we'll have a plus 2 in front. Sine 2x over cosine squared 2x. I can split up the cosine squared and write this as secant of 2x times tan of 2x dx. But now at this point, we've got two really easy integrals, right? We've got secant squared and secant times tan, and we know how to do these. So for this first one, this is going to give me 2 tan of 2x, but we need to consider this 2 coefficient and divide by 2 here. And then for this one, integral of secant times tangent is just going to give me secant of 2x. But again, we have the 2 coefficients, so we divide by 2. We'll put a plus c on the end. We'll cancel these 2's. And so we have a solution tan of 2x times secant 2x plus c. Now this is a fine solution here, but I noticed in the answer key, and what they did is they put it back into the form of sines and cosines and just x as the angle. So I think what I'm going to do is some trig identities to try to get this answer into the form that MIT had it. Okay, so to transform this thing, what I'm going to do is I'm actually going to put it first back into sines and cosines. So tan of 2x I can write as sine of 2x. And we're going to have cosine of 2x in the denominator, but we're going to have it for both these. So I'm just going to, in one step, put it under 1. I'm going to put this together all into one fraction. And then secant of 2x is just 1 over cosine 2x. So I can write this as sine of 2x plus 1. And then from here, I can use the double angle formula for sine of 2x. What we used originally, we said 2 sine x is sine of 2x, but I'm just going to put it back and write this as 2 sine x cos x. And then for 1, I'm going to do a little trick here. 1 is the same thing as this. I'm going to write my 1 as sine squared x plus cosine squared x. And then for cosine 2x, I'm going to use the double angle formula there and write this as cosine squared x minus sine squared x. And notice now we have everything back into sine and cosine, and we got rid of all of our double angles and put everything back to single angles. But now what I can do is factor this thing, because you'll notice that this in the numerator, this is actually the same thing as sine x plus cosine x squared, right? And then this we can factor as the difference of two squares. We can write this as cosine x minus sine x times cosine x plus sine x. But now at this point, notice that this here is exactly the same as this right here. So I can actually cancel one of these. So I'm going to cancel cosine x plus sine x with just one of these. And then that's going to give me the final solution that matches the MIT solution key, which is sine x plus cosine x over cosine x minus sine x plus c, and that's it. Okay, so again, good problem. Let me know if you had some more creative ways. I know I just did the straightforward method, but I'd be interested to see if you had some different ways of doing this. So we'll stop it there. Thanks everyone for watching. Have a great day.